Hello everyone, my name is Edward. This module is all about data collection and pre-processing. This video is about future extraction of text data. In this video, I will explaining you what is exactly mean by future extraction and how we can implement this future extraction of text data using Tf-Idf Vectorizer. So I will also be showing you can implement this in Python. This also contain Amazon part. First of all, let's try to understand about this future extraction. The mapping from textual data to real values vectors is called future extraction. I would like to explain you about some basic thing about machine learning here before going into future extraction. Basically, in machine learning, we will feed our machine learning model with a lot of data, and the model can find the patterns in this data, and it can learn from it, as a result of which it can make new predictions. This is how a basic machine learning algorithm or model works. But when we have the data in the form of text, it will be kind of hard for a computer or a machine to understand the text data, whereas it can easily understand the numerical data. We have to convert this text to data to numerical data. This is where future extraction comes into play. We convert this textual data to future vectors. Future vectors are nothing but the numerical representation of this textual data. This is called as future extraction. Once we convert this textual data to numerical data, it is now compatible to go into the machine learning model. We need to discuss some few terms in terms of future extraction. The first one is bag of words. As you can see here, bag of words represent the list of unique words in the text corpus. Corpus means collection of words. Let's say we have a paragraph. This future extraction algorithm tries to create a list with all the unique words. It removes the repeat words and it creates a list of all the unique words present in that particular text purpose. Then we will use our Tf-Idf Vectorizer. Tf-Idf represents term frequency and inverse document frequency. In the next slide, I will explain you what exactly meant by this term frequency and inverse document frequency. First, try to understand what does this Tf-Idf of Vectorizer do. As you can see here, I have mentioned it here that to count the number of times each word appears in a document. We create a list of all the words in the paragraph or in the document, and we count the number of times the words repeats. You may have a doubt how does counting the number of words can help us convert this text into numerical data. I will give you an example. Let's say that we are building a machine learning model that can predict whether a mail is a spam mail or normal mail. We all would have encountered this spam mail in our daily life. And we can say that the spam mails contain the words like offers, free, discounts, and such kind of things, and the normal mail. The mail sent by our family members or our colleagues does not have this kind of words. When you count these words, it can tell the machine learning algorithm like this particular kind of label as this kind of watch. For example, the label for this spam in prediction will be spam mails, and normal mail site. And here these families will be the label. This can tell our model that these spam mails has the words like free, discount offers, etc. This is how counting the words can help the machine learning model to understand what is present in the dataset. That is another important thing to note here. When we do this vectorizer, it does not understand the context of the paragraph. It just tries to count the number of words. Number of times the words it repeated, and it does not understand the context. There are also some other methods which we will discuss in our NLP topics, which is natural language processing topics. In that part, I will explain you what are the other methods to do this, but in machine learning, we frequently go with these vectorizer concepts. I have told you what does this vectorizer do. Now, let's understand more about this term frequency and inverse document frequency. We will be using a Tf-Idf Vectorizer, and Tf stands for term frequency. You can see the formula here. The formula for term frequency is a number of times term T appears in a document divided by the total number of terms in the document. There is a word called as offer in that particular dataset. This vector result will count how many times this word offer has been repeated in the document, and it will divide it by total number of words present in the document. This is called as term frequency. This can tell us what are the important words or not. This IDF stands for inverse document frequency, and the formula for this is log capital N by small n. I have mentioned it, what has been made these two N and C. The capital N stands for the number of documents, and small n stands for number of documents a term T has appeared in. You can refer the formula. Basically, what it tells us. The IDF value of a rare word is high, whereas the IDF of a frequent word is low. Why we have this inverse document frequency value is that there can be words like the articles and other kinds of things. Words like these are the etc. These words would be repeated a lot of time, and we don't want to give a significant focus to these words. This is where we use this inverse document frequency, where if a word repeated a lot of times, that word will have a small value. This will tell us the machine learning model that the word is not significant. Then both of these values will be multiplied. Tf-Idf value, and each term this is nothing but our future vectors. It represents the numerical value. As you can see here, we got some numerical values from these formulas. This is how we can convert the text data to a numerical data. I hope you have understood what we have discussed. Now, I will show how you can implement this in Python. Now, let's log into Google Colab and do it in the code section. Now, about the dataset. First, ID, unique ID for a news article. 2, title. 3, author. 4, text. And 5, label. Real news or fake news. We have taken this fake news prediction dataset. This dataset contains news article, and it contains two types of news. One is the fake news and the another one is the real news. You can see the data of the dataset here. I am going to explain you how we can convert this text data to numerical data. I will just give you a short introduction of what we are doing here. Now, we have the necessary libraries. So, import numpy as MP, import pandas as PD, and import array. Array stands for regular expression. It is very useful for searching the text in a document. Now, from nltk.corpus import stop words. NLTK stands for Natural Language Toolkit. Corpus generally means the body of that particular text, the important content of the text. And stop words basically means those words which does not add much value to a paragraph vertex. These can be the words such as the a, and so it can be the articles, or it can be the words like where, what, when, those kinds of words. Those words are stop words. We need to remove this kind of stop words from our dataset because it does not add much value about the context of the data. That's why we need to import this topic using this function. And now, from nltk.stem.porter import porter stemmer. Stem, we will perform a function called a stemming. This stemming takes a word and removes the prefix and suffix of that word and returns the root word of it. This is the general description about stemming. Portal stemmer, this function is used to stem our words. It basically gives us the root for a particular word. And now we write from sklearn.futureExtraction.text import Tf-Idf Vectorizer. This Tf-Idf Vectorizer function, this is what we are going to use to convert the text into future vectors. Future vectors are nothing but numbers. This is the function we will be needing. We just imported the libraries. Now, let's run this and move on. Now, we have need to download these top words from NLTK library. So, import NLTK. Now, NLTK dot download parentheses and quotes stop words. Now I run this. This will download all the stop words present in here. Now let me show you what are these stop words. So I will print these words. Print keyword parentheses stop words dot words parentheses quotes English. So these are the stop words I have told you. As you can see in these words here. I run this. This words does not add much value to our dataset. During the stemming procedure, we will also remove all these words from our dataset. These are nothing but the stop words. Now, let's continue our code. Once we have imported all the dependencies, we have downloaded the stop words module. Now, this is data collection and data processing part. Now I click text button and to write. Data preprocessing. Now we need to load this dataset into a pandas data frame. Now I create a comment here and to write. Load the dataset to a pandas data frame. Pandas data frame loads the dataset into a more structured table. I will create the variable as news dataset, news underscore dataset. So we need to use the function which is equal to pd.readCSV. Now let's go to our dataset and copy the path. So right click, upload, and upload dataset. Now let's go to our dataset train.csv and copy the path and paste here. So I will run this and move on. Sorry. We get invalid syntax. Sorry. Single quotes put. Yeah. Now let's check the number of rows and columns in the dataset. So news dataset variable dot shape. I run this. So we have 20,800 news articles and 5 columns. So we have 20,800 news articles and 5 columns. Now let's try to print the first 5 columns of this dataset. I create a comment here and to write. Print the first 5 rows of the data frame. You can do that by using the function hid. So news dataset variable dot hid function. I run this and see the result. As you can see here, this is the ID which we have seen above. First, we have the ID column which gives the serial number of the news. Then we have the title of every news. Then we have the author of that news and we have the text in this dataset. This is the detailed explanation of this news and we have labeled. So label. The labels will be either 1 or 0. 1 represents fake news. 0 represents real news. This cite the sample of our dataset. Now we need to check whether some values are missing in this dataset. Now I create a comment here and to write. Count the number of missing values in the dataset. You can do that by using the function isNull. So, news dataset variable dot isNull and dot sum. So I run this and see. As you can see here, there are no missing values in the ID, this serial number column. Their title column, we have about 558 missing values. Their author column, we have about 1957 missing values. And text column, we have about 39 missing values. Let's understand why these things are missing. Basically, it means while we are preparing the dataset, we may not get the title of a news or author of a particular news or the text of a particular news. That's the reason for some news we may have only the title and author. In that case, the text will be absent. So, similarly, we have the title and the text for some news, but the author name is missing while we are preparing the dataset. That's the reason. In this case, we have a very large dataset because it has almost 20,800 news articles. These missing values are not that much important. We can drop these missing values or we can replace it with null string. But if a lot of the values are missing, we will use some methods like imputation. In that imputation method, we will do some processing to replace those missing values with appropriate values. In this case, we don't need to do that because we have enough dataset to train our machine learning model. If we have a very small dataset, in that case, we cannot drop the values because we already have a very small dataset, and in that if we drop some values, we cannot make good predictions. But in this case, as we have a large dataset, we can replace the missing values with null string. Null strings are nothing but empty string. Now I create a comment here and to write. Replacing the null values with empty string. So news dataset variable, which is equal to, I am creating the new variable, which is the same as our data frame name. So news dataset dot fill now parentheses, this will fill the missing values. This fill your name fills the missing values with whatever we need to fill. So I run this. Sorry, we get value error. Sorry. Now we don't need run this. This will, your name fills the missing values with whatever we need to fill. Here I will mention a null string. So I put single quotes. Null string can be mentioned by just putting single quotes or double quotes. This is a null string. Now I run this and move on. This replaces the missing value with null string. This is one of the important steps in our project. For our prediction, we are going to include title and author. Now, we will combine this title and author together, and this is the data we are going to use for prediction. We are not going to use the text because these texts are so large. It can be a hook paragraph and it takes a lot of time for processing. Now I create a comment here and to write. Merging the author column and title column. These are the two main important features required for us. So I will mention data frame name, news dataset. I will create a new column named as content. So I put square brackets, single quotes, content column. I am going to store this combined value of title and author in that column. Let's mention in here. So this is equal to news dataset variable author plus, basically this plus symbol concatenates two strings. I want to separate them with the space. I want to combine with author column and title column. Now I run this and move on. Now print our dataset and see the result. News dataset variable content column. I run this. As you can see here, first we have the author name because we have mentioned the author name and the title next. So we are going to use particular data to make the prediction. We will be using this content data and the labels to make predictions. Now we need to separate this particular data, which is the content column, and labels separately. Let's do that. Now I create a comment here and to write. Separating the data and label. I create the variable as x, which is equal to new dataset variable dot drop parentheses columns label and axis is equal to 1. Basically, I want to remove this label out of this data frame. I don't want to give this label together with the data. In this data frame, I remove this label and store all this data in one variable and then store this label alone in one variable. This drop function is basically removes the label column from our data frame. This drop function is basically removes the label column from our data frame. If you are removing a row from a data, you need to mention as axis is equal to 0. But in this case, we are removing the column and by mentioning the axis is equal to 1. Now, I am creating another variable called as y, in which I will store all the label. Y is equal to new dataset variable, square brackets, single quotes, and label. This will load all the label value to my new variable called as y. Now I run this and move on. So I can print these x and y variables. Print keyword parentheses x variable and print y variable. Now I run this and see the result. As you can see here from our original data frame, all of these values except the label will be stored in x variable and label value will be stored in y variable. We are not seeing these other columns such as title, author, because it will be not shown because of the reason it is showing these 3 dots. It basically means there are several columns between it. These columns are nothing but our title, author, text, and content columns. That's why it's just printing the content column alone because there won't be enough space to print the entire thing. So we have totally 20,1800 rows and 5 columns. Now we need to do the stemming procedure. Now I create a text here and to write stemming Stemming is the process of reducing a word to its root word. I have told earlier stemming will remove all the prefixes and suffixes because they don't give much meaning to our text. For example, let's say that we have several words such as actor, actress, acting. So, example, actor, actress, acting. For all these words, the root word is act right. Act word. All these words, the prefix and suffix will be removed and the main root word will be captured. That is what we are going to do that in the case of stemming. This is a very important step because we need to reduce the words as much as possible to have better performance on our model. Once we do this procedure of reducing the words to its accurate root word, we will perform the function of vectorizing. In that vectorizing step, we will convert these words to their respective future vectors. Future vectors are basically the numerical data. Once we convert this text data to a numerical data, we can feed it to our machine learning model. Here you just need to understand that stemming is the process of reducing a word to each root. We import in the Porter stemmer library above. This is function we are going to use for this purpose. Now, I create a variable named as port underscore stem. This is equal to Porter stemmer parentheses. This Porter stemmer function will be loaded to this port stem variable. Now I run this and move on. Now I create a function def define. This def means basically define. In some cases, you need to replicate a particular code snippet. We cannot do the same code again and again. For simplifying several lines of code to simple word, we use this function. Now, I am creating a function called as stemming. Stemming, parentheses. In parentheses, you need to mention some input value. So, content. Endpoint. We will be by this procedure. We will create a function and the name of that function is stemming. And in the bracket, we need to give some input value. This word content particularly represents the input. I want to name this input as content. It's not that this is the same word that we specified above as the column name. These are the different words. This function we are going to use for stemming our text data. This seems very complicated to you, but it's actually very simple. Now, I create a variable named as stemmed content. Stemmed content is equal to re. This means regular expression library. We are importing this above. It is useful for searching paragraph for text. I am using this function called the sub. Sub function and parentheses. Sub basically means substitute as values. In this I have mentioned this upper arrow. So we need to put upper row. This means an exclusion. I have mentioned a set which contains small a to small z. So square brackets and single quotes. Then we mention capital A to capital Z. I need to get all these alphabets. In our data set can be numbers, commas, quotes, and a lot of things. For this, we don't want all of those things. We just want all the alphabets and words. For this, we are taking this set, lower to lower z and uppercase A to uppercase Z. This is our set and we are excluding upper row everything that is not present in the set. There we mention space. So, comma, single quotes, space basically means if there is numbers or commas, quotes those will be replaced by a space. I want all this to be replaced by content. So, comma, content. This content basically means the text. I want to fit this content column. This content column basically represents the title and author column combined. I want to fit this data to this stemming. That is the purpose of this step, which to remove all those things from my content except for alphabets and words. I want to do this processing in my content, which is basically the combined form of the author name and text name. Once we have done that, we need to convert all the alphabets to lowercase letters. So, stemmed content is equal to stemmed content dot lower. Some words can be in uppercase letters. I want to convert all those to lowercase letters because it can create some problems in processing the machine learning model or other processing. May think that uppercase letters means some significant things. I convert all the words or the letters to lowercase letters. It is very helpful. Once we done that, we are splitting it to respective list. All these words and text will be converted to list. So, stemmed content variable is equal to stemmed content dot split. It will be splitted and it will be converted to a list. And now, stemmed content variable is equal to square brackets or stem variable dot stem parentheses and we will write word. Now we are stemming this word. We are taking each word and we are doing this stemming function. This stemming, which means taking a word and reducing it to its root word. We need to do it in all the words, but in this case we are removing the stop words. We have earlier printed these stop words. Now I am just using a for loop to parse in my data frame. So, stemmed content is equal to square brackets word stem variable dot stem word for word in stemmed content if not word in stop words dot words English. I delete this. I remove all the words stop words and choose only the words that are not the stop words. As you can see here, for word in stem content. In my content, I want to take the word if it's not in this stop words library. I am taking all those words that are not stoppers and I am performing the function port stem, which means port stemmer. Now, stemmed content variable, which is equal to single quotes join function stemmed content variable. Once I have done that, I am joining all the words. This is the stemming function. So return stemmed content. Finally, we will return our processed text, which is stemmed content. Now I run this and move on. Now we have created this function. So news dataset variable content column is equal to news dataset content dot apply function stemming. So I am taking the content column, which is the join form of the author name and title name of the news article, and I am applying the stemming function. This will do all the processing in this stemming function, and it will return that to a new column called as content. The same column in this data frame. Now I run this, and this will take a minute or two because the processing has to be done for a lot of words. Another important thing here, if you practice this code here, there is a good chance this will throw an error because you need to pay close attention to this symbol here. Here symbol. In some systems, this Unicode symbol cannot be replicated. If you face some error in your code, what you should do is download the collab file from the description. Once you are making the code, just make sure that this symbol is the same. Now we have applied the stemming procedure. Now let's print the stem content. So print keyword news dataset variable and content. I run this and see the result. Now, as you can see here, we don't have any uppercase letters. You can see this content before processing, we have a capital letters in almost all the words, and then we have a lot of functions, codes, etc. All those will be removed. The words will be converted to their respective root words. All the stop words, which are insignificant, will be removed from this dataset. That is the reason for doing this stemming procedure. Now, let's create again the x and y. We just need this content value for our processing. I am not using this text column because if we use this tab, will be a lot of processing because each of these text will be a whole paragraph and it will take a long time for processing. But if we do the training with this title and author alone, it will yield a very good result and it is very easy for us. I will just separate this column. Now I create a comment here and to write. Separating the data and label. So x variable which is equal to news dataset variable content dot values. I want the content value to be in this dataset in x variable. I want the labels to be in y variable. Y variable which is equal to news dataset content dot values. Sorry, label. Now I run this and move on. We don't have to make this particular cell. We don't have to just make this equivalent cell. I made this because I wanted to show you that the dataset can be splitted by this. I am just getting this content column and the label column. Now I print x variable. I run this and see the result. This x variable will be our data. There we have a lot of values. Previously, we have all the columns such as ID, title, author, etc. So I want only this content column, type storing this content column to x. Now let's print to y variable. Print y variable. This will show the label. I run this. So 101011. So 1 means fake news and 0 means real news. You can check the shape of y. Y dot shape. Shape of y is nothing but 20,800. In this particular variable y, we have 20,800 values. All those values cannot be shown here. That's why has shown this is not short form by 3 dots. This is the thing we are going to fit our machine learning model. We have this content column in X and label column in Y hour. We have this content column in X and label column in Y. Now, this value is still in textual form. I have told you earlier that computers cannot understand text. We need to convert all this text into meaningful numbers that the computer can understand. We will be using this import Tf-Idf Vectorizer function. Now I create a comment here and to write. Convert the textual data to numerical data. Now I will create a variable called as Vectorizer. This invariable we store vectorizer function. So this equal to Tf IDF Vectorizer. Now I run this and move on. Now you can feed the value. Vectorizer function dot feed and feed x variable. Now let's keep the text. X variable is equal to vectorizer dot transform x variable. We are using special vector. It is called Tf-Idf Vectorizer function. Tf stands for term frequency. IDF, inverse document frequency. It basically counts the number of times a particular word is repeating in a document, in a particular text paragraph or something. That repetition tells the model that it is a very important word, and it assigns a particular numerical value to that word. That is the purpose of this Tf-Idf. It stands for inverse frequency. Sometimes a word which is repeated several times does not have meaning in it. Let's say that we are building a system that predicts whether a review is a positive review or a negative review for a movie. Let's say that we are doing this for the Rangers movie. There are a lot of reviews in the internet and we are analyzing all these reviews. When we perform the same things, here all the reviews contains the movie name Rangers. In that case, the repeated word, which is Avenger, does not add any value to it because all the previous is definitely going to contain the movie name. This inverse frequency function finds those values which are repeating many times and it detects that those words are not significant and it reduced its importance value. But this term frequency finds the number of repeating significant words and it will give a particular value to it. By this they create future vectors. Future vectors are nothing but numbers. X variable is nothing but this content column. All these words will be converted to their respective future vectors. We don't need to do in the case of y because y variable is already a number. Y variable is already our label. We are fitting x variable. Transform. This function will convert all these values to their respective futures. Now I run this and move on. Now let's see a sample of x. So print keyword parentheses and x variable. Before it was text, right? As you can see here, before it was only text. Now it is converted to their respective future vectors based on the function of Tf-Idf Vectorizer. This is how you can convert a text to a numbers that the system can understand. I run this. Now we need to feed this data to our machine learning model to predict whether this news is a real news or a fake news. Let's get to know each other in more detail and do it on my channel Fake News Prediction using my machine learning with Python. So I hope you have understood all the contents covered in this channel. I will see you next video. Thanks for watching.